and its derivative function f prime. And so this blue function right here is the function that we looked at as an example of a graph of a particular function f, and we try to draw a sketch of f prime. And so what I want to show you is this is an animation. So let's play. Okay, and what you'll notice about this animation is that we have our function f, which is the blue curve, and then we have the red tangent line. So we've got a particular point on the curve, and the red line creates a tangent line. And the number that's rotating up here is the slope of that tangent line. So if I were to say pause right here, you'll notice that that number is positive because our tangent line is increasing. Okay? So our tangent line is a positive slope, and so our derivative is a positive number 22. And so if I slide my point over so that we're right at the top of the hill, well, if I get as close as possible there to the top of the hill, well, right around in there is where our slope is almost 0. And if you watch this tangent line, when the tangent line is going downhill, okay, which is also the place where our function f is decreasing, our derivative is negative. And where our function is increasing, our tangent line is going uphill, and our slope is positive. Okay, so what we did last class is that based on this blue function right here, based on that function, we drew a picture of f prime. And the first thing we did is figure out where the flat spots were on f, and that's where our derivative was equal to 0. And so I have a second picture here that I'd like to show you. And on this graph, we have our original blue function, original f, and then this neon green function up here is our f prime. And so what you'll notice is that on this picture, let's slow down here. On this picture, if I back this up so that our tangent line is at the bottom of a bowl down here, so our tangent line is completely flat, our tangent line is a slope of 0, that's where f prime has an x-intercept. And from that particular x value until a little bit after 2, our f function is increasing, and so during that time period, f prime is above the x-axis. And you can follow both of them. So f prime above the x-axis, f increasing. F prime above the x-axis, f increasing. No, stop, back up. Here we have another place where f prime is 0 because f is flat. And then we can continue on. F decreasing, so f prime is negative. Here, both f and f prime are equal to 0. F is flat, so f prime has a height of 0. Okay, so I'll let this play. You can observe some different things that are happening. And what I'll do is I'll post the code for this on our website. So after next Tuesday, after you've had an introduction to Mathematica, you can copy and paste the code from the website, put it in the Mathematica file, and then you can open this and play around with it all you want. And in fact, and I'll point this out now, the very, very top line up here is the name of the function, x plus 2 times x minus 1 times x minus 4 squared. And so if you want to change that to a different function, for example, rather than this function, we might look at sine of x. Now we've got, well, let's go down to the bottom one down here. Now we've got our sine of x function, and then we have our f prime function as well. So you can play around with that, change your function, and mess around with this all you want. Any questions about that?
So